All right, we're going to continue our limit thing. On the last video, we took the whole idea of a limit is we're going to plug it in, but if we plug in the value, sometimes we get a 0 over a 0, which is not helpful. Usually that tells us that we have a hole about to happen. So we need to either factor some values and then remove the problem, or we're going to multiply by conjugate if we have any kind of a radical in it. And then that kind of manipulates our equations into different versions that then we can plug in our values to figure out what our limits are, right? And so we're going to do one more that again is a little bit more complicated. And so this time we're going to be looking at limits on the left side, the right side, and then the overall limit. Okay, so we're going to have kind of three problems in one. But before I dive too deep into this, I have a bigger issue kind of going on, is that we have a denominator. So our denominator can't be 0. And so we have a value that would make our denominator 0. So we'll have to kick that out. And we have a square root. And square roots need to be positives. Right? We can square root 0, but 0 ends up being a problem because it's in the denominator. But so our domain is we would want values that are greater than or equal to 2 here, because that would keep our square root as being a positive. However, we also don't want it to be a 0. So our domain needs to be greater than 2. Well, that actually causes a problem on one of our limits, this one, because this limit was looking for x's that were less than 2, and on the left of 2. We can't have values on the left of 2. So we're going to need to adjust here a little bit. So and we'll do that in just a second. Adjust. Okay, so before we do all of that, though, we still have this fact that let's rewrite it, manipulate it, kind of take care of some of this. So this is already going to be a problem. Let's not lose that fact. But this also, if we were to plug in 2, there's probably a good chance that we're going to get a 0 over a 0. So let's start to factor. Let's see what we can do to kind of manipulate and cancel some stuff out. Right, so this thing, if you take a factor out, or an x out, you'd have x squared minus 6x plus 8, right? And then if that factors further, let's start to do it down here. We would have what multiplies to 8 that adds to -6. We would have a -4 and a -2 over this square root. Okay, so the x minus 2's are pretty darn close to canceling each other because that ends up being the problem. And so the only way that we can manipulate it to where they would cancel each other is we would multiply the top and the bottom by square root of x minus 2. Right, so if we did that, I'm not going to distribute it, but these two would undo each other. At least the square roots would cancel out. And then we would be sitting with x minus 4, x minus 2, and then the square root of x minus 2 all over x minus 2. All right, so this is us just kind of manipulating it a little bit, factoring, multiplying out a square root, and then this goes away. So really we have left, we don't even have a fraction anymore. So if we don't have a fraction anymore, we don't have a possibility of having a 0 in the denominator. So, but everything we do, I know we've manipulated, but it's still based off of the original. So here's where some of the limit stuff starts to happen. We talked about that this one already has an issue, right? Based on our domain, we can't plug in anything less than 2. It would cause this to be an imaginary number, and we're not looking to do that. And so just this piece, let's try that again, just the negative. So to the left of this is not a possibility. So this already does not exist. Okay, which also means that you don't have an overall limit, because the idea of the limit is I need to be approaching the same thing on both sides. And as soon as this thing goes to does not exist, well, this one's not going to happen. Right, so it's not an asymptote. It's not anything like that. It just literally doesn't, there's no values for it. So this will also be, it does not exist. But let's figure out what this is. So, and just to kind of make note, this is the domain is x is greater than 2. So there is no to the left of 2. All right, so let's go on the other side. The limit as x approaches 2 from the right. Okay, this one's okay. We can do values greater than 2. So let's do the math on this. So our equation is this, right? We've manipulated into this, and this is absolutely okay for us to plug into. So we'll have a 2 minus 4, and then square root of 2 minus 2. All right, so that math is 2 times negative 2 times square root of 0. So that's 0 times whatever is going to be 0. So our limit as x approaches 2 from the right of that original function would be 0. It would be approaching 0. And then our overall limit, we're not going to have, because we don't have a left side of this equation. The idea of a limit is that the both left and right side need to equal each other. So this is a does not exist. And kind of your fancier explanation to this is the limit of x approaches 2 from the left does not equal the limit as x approaches 2 from the right. And that is why we don't have an overall limit. All right, so that was probably about as hard as they get for those types of situations. And again, I don't know the graph, so I don't have a whole lot of information. So I kind of just need to start digging into domain issues, maybe plug in the 2 and see what you get. And then kind of based on that, you start to manipulate it, factor it, conjugates. If you have square roots, you may involve a conjugate, or you just may involve the actual whole thing. So you can cancel that out and then see where it goes from there. All right, and then we'll start to do some other problems in other videos.